Hi everyone. Today I will be talking about building data quality program. So over the past few years, there has been a dramatic shift in focus in information technology. From the technology to the information, organizations are now beginning to realize that their competitiveness will be based on their data, but not just on technology, and that their data and information are among their most important assets. In this new data-driven environment, companies are increasingly utilizing analytical techniques to draw meaningful conclusions from data. However, the garbage in, garbage out rule still applies. So data quality aspect becomes even more important. So here I am to share about DAIC approach derived from Six Sigma Methodologies to help improve the level of data quality effectiveness and efficiency in any organization. This four-phase define, assess, improve, control approach. We also term it as DAIC. So this approach is to carry out data quality programs in a systematic way, right from initial planning to complete implementation. In define phase, we define baseline objectives and scope, develop a project charter, role clarity, and project plan. We also obtain stakeholder commitment during this phase. In assess phase, we define critical data elements and business use, develop data collection plan, conduct data quality assessments, and update metadata. In improve phase, we implement issue resolution process, conduct root cause analysis, perform solution analysis, and commission improvement efforts. At end, in control phase, we establish control processes for ongoing monitoring, establish service level agreements, formalize change management, determining required scorecards, dashboards, and reports and metadata processes. So now let's look into details of each stage in this quality programs build up. Define phase. Now define phase focuses on defining the project by establishing the scope, objective, resource commitments, project plans, and also ensuring strong governance and stakeholder support. Broadly, there are two approaches for defining the overall scope of the project. So one approach of establishing data quality project scope can be by selecting data critical to the targeted business process. In this approach, we focus on understanding the quality of that data, supporting this critical process, and establishing ongoing monitoring, likewise in support of the given process. Any resulting data quality issue are then investigated via root cause analysis, and remediation is managed through an established issue management capacity. Another approach for establishing data quality project scope can be by selecting from the set of known data quality issues collected during the current state analysis. In this approach, the project focuses on resolving key chain and key pain points with the quality of the data used in a given business process. Three prime activities in define phase that we should follow are creating a project charter as part of the define phase, having the role clarity around them, and creating the project plan. Now, if we talk about defining project charter, that is most important activity in define phase. We need to start with an end in mind. Project team establishes scope and expected business value and create project charter accordingly. Charter needs to frame data quality project and determine the objectives, scope, key participants, resources. It should also outline broad time frame and core deliverables. So to be specific, project charter need to have project objectives, stating clear objective that can be evidenced by a success measure. Project scope, detailing scope statements that define process, systems, and data that will be included in the effort, as well as outlining goals and intended outcomes. Highly effective teams should have clearly articulated roles and responsibilities. So likewise, in define phase itself, team must clarify roles related to data quality project and identify all responsible parties. Typical roles are project sponsor, project manager, technical analysts, operational analysts. Typically, project executive sponsor plays project sponsor role, but it is vital that other key executives and managers also participate, particularly from the given business line. Project manager. Project manager is responsible to ensure projects are kept on track. Issues are identified and raised, and resources are coordinated appropriately. Data quality analyst is someone who is responsible for majority of the work conducted in the project. DQA conducts profiling, assessment activities, leads working sessions, and builds key deliverables. It is absolutely essential that the DQA be skilled in data quality and understand how to conduct the associated profiling analytics and build data quality rules. A goal without a plan is just a wish. So project managers need to prepare a detailed project plan for all 4 phases of the DAIC approach with the tasks, milestone plan, and associated deliverables. So this is about define phase. Now let's check what happens in assess phase. During the assess phase, the project team should focus on establishing and assessing a data quality baseline for the critical data as outlined in the define phase. The project team deploys profiling and assessment techniques as well as gathering the business data quality requirements for the given data. This requires the participation of business subject matter experts, SMEs, data quality analysts, DQAs, operations, managers, and data owners and stewards as they focus on translating business and operational requirements into data quality rules as well as pulling and analyzing data. The assess phase ends with the production of data quality scorecards, which provide a clear baseline of the current state of data quality for the given critical data set. Let's look into several activities that we perform in assess phase. So we start assess phase by identifying critical data elements. It can be impractical and a poor use of resources to measure every data element in a given data set or system. It is important to narrow the focus of assessment and monitoring the critical data only. That is, to the data required to support the key outcomes and deliverables of the business. Critical data identification is based on assessment of the business process and associated key outcomes of that process. Analysis of those key deliverables such as management reports, client statements, product analysis should provide a candidate list of critical data elements. Subsequently, that list can be prioritized based on existing issues or business goals, and statistical analysis, resulting in a finite set of critical data elements or attributes. As with many of activities in the methodology, this analysis should be done with business, operations, and technology analysts. The data quality analyst needs to work through any existing data models and data dictionaries to understand how these attributes are reflected in the given target systems. So that's why next step comes around developing data collection plan. Once business use requirements have been established, the technology and operations teams need to define the data sets and key points in the data and process flows that should be used for profiling and assessment. In addition, the plan for accessing and staging that data for both initial assessment and ongoing monitoring and control going forward needs to be developed. Here, the data quality team must understand where and how data flows from system to system. Integration activities, the normalization, mapping, transformations that occur, and access to existing data models and dictionaries for target systems. Then data quality analysts use standard data profiling techniques to discover composition and nature of the data contained in the target data set and for critical data attributes defined in early activities. This includes basic analysis of missing or null values, assessment of validity against known reference sources, and checking of data patterns and formats, as well as more sophisticated analytics. Leveraging the results of the profiling exercise that comes with the data profiling with input from subject matter experts in the business, operations, and technology areas, then data quality analyst begins to define and implement a series of data quality rules for the critical data that will drive the baseline measure. Again, these rules define the measurement of data quality based on the requirements established by the business use of the data. And they form the basis for assessing the critical data and understanding its quality. The measure of data quality and the rules themselves are expressed in terms of dimensions of the data quality. Yeah. Although we consider that there are 9 dimensions on which data quality can be measured, but 4 among them are core. That is completeness, conformity, validity, and accuracy. This is by and large an iterative effort involving running the results, validating those results with the subject matter experts, and refining the data quality rules that drive those results. The data quality analyst plays lead role, but this work takes input from those who understand the data sets and their uses. At this point, the data quality analyst works with the business to determine the threshold for any given attribute and dimension. Questions such as, is completeness 95% enough? Yeah, or acceptable? That must be answered. These statistically determined thresholds should be modified based on subject matter expert inputs in order to have more practical numbers to work with. In case where we cannot statistically determine the thresholds, we must resort to subject matter expert inputs to determine this number and refine this process as we collect more and more data. The result of the assessment is a set of error records organized by attribute and data quality dimension or rule. The assessment activity should identify all those records that are incomplete, non-confirming, invalid, or inaccurate. These records are the basis for the root cause analysis conducted in the next improve phase. Also, a data quality scorecard is created in this phase. These scorecards show a summary of the data quality of the given assessment results. Scorecards should be built in such a way that they allow identification of good or problem areas by business areas, systems, attributes, various points in the data or process flow. Typically, the scorecards are populated with percentage errors by attribute and dimension. However, they should also include the details that are reflected in the key business measures. For example, the number of client balance, pending payments, or number of transactions reflected in error records. This gives a measure of business context and impact. These scorecards can also reflect the number of records tested versus failed. Yeah. As last activity in the assess phase, updation of the metadata needs to happen. Why? Metadata collected should be well organized and captured. A strong metadata governance process should be established to include use of standard tools as well as allowing for general access and use of the information gathered. This effort definitely includes validation and certification from business, operations, and technology. Now, D and A we have covered. Let's understand what do we do in the improve phase. The improve phase of the DAIC approach focuses on conducting root cause analysis on data quality issues identified during assess phase by data quality and business teams. These issues should be logged into the issue management system. Then further, data quality team develop process, technology, and data cleansing solution for addressing these issues. Activities focused during this phase starts from implementing on the issue management process. Now, what is that? Where the thresholds get identified by ongoing and periodic data quality assessments that need to be recorded along with the necessary information required for use in root cause analysis, issue status reporting, and ultimate resolution. Then, data quality analyst using standard methods conducts analysis of the error records. That needs to be understood where the problems are happening, why it is happening, yeah, and how to bring in the countermeasures so that those problems will not occur. Where necessary, work with the technology and operations teams to find the source of the issue and question. In the end, whenever possible, data quality errors should be remedied at the source and also should be mitigated at the source to avoid that to happen again. First time, right. Once the root cause has been identified and discussed with the executive sponsor and the business area, business and technology analyst can begin designing solution alternatives. During this process, they need to understand what is the return on investment for implementing any solution in terms of risk, revenue, cost avoidance, and so on. Then team can prioritize the recommended solution, particularly where there may be competing potential alternatives. Prioritized and agreed upon remediation and improvement efforts must definitely be commissioned, and resulting initiatives are tied to the issue management process so that we close the loop, over here. This ensures that management teams and executives have visibility to the data quality improvements. The last phase, that is the control phase. As Aristotle said, quality is not an act, it is a habit. So define, assess and improve is not going to give us long-term benefits if we won't control countermeasure as well. So the control phase of the DAIC approach marks the business as usual implementation of monitoring scorecards, outstanding data quality issues inventory, and the root cause remediation plan for the outstanding issues and data quality improvements for any projects currently underway. During this phase, production scorecards and dashboards are built. Ongoing control and monitoring processes are put into place. And operational owners and escalation routines are formalized. Activities in the control phase serve as the basis, as a foundation for continuous improvement, as ongoing monitoring, analysis, and planning activities drive additional assessment and improvement efforts. This further represents the implementation of the steady state operating environment in which the data quality capabilities are in place. Now, in a steady state monitor and control operating environment, the target data and systems need to be defined. Data quality project, the data quality analyst should conduct profiling and analysis on this data and on collected metadata. Also, DQAs should execute the initial assessment against critical data elements and implement the associated scorecards. In many organizations, data flows from system to system in a non-linear fashion, to the surprise, right? So when we started our careers, then we always thought that data actually should be getting flowed from system to system, process to process in a linear fashion, but hardly it happens. It is in the non-linear fashion, and that's more normal, right? But then as data quality capabilities are put in place and assessments are conducted, it is important to establish formal service level agreements. Everything, whatever we are trying to achieve in define, assess, and improve, if service level agreement is not there, then everything will fall off. So things that you want to control, you need to measure them. So critical data and associated data quality levels should be explicitly discussed along with the stakeholders' management of the issue resolution process. Then there is need to establish process for managing changes made to requirement and metadata as well. Like, data quality rules, like critical data elements, right? So critical data elements can also keep on getting changed. Need not to happen that, once you are defining critical data elements, they are going to stay forever, right? So priorities do get changed, processes do get changed, and does critical data elements also get changed. Scorecards, yeah, stewardship, etc. on an ongoing basis. This process also manages changes to the data collection plan and technology toolset or the environments, in which they are run. The key in this phase is to establish strong governance routines around the management of this metadata. Over time, rules will be enhanced. They will be modified, they will be deactivated, more rules will come, additional scorecards will be developed, and data models will be collected. All this information is critical for continuous improvement efforts. The data quality team need to work with various consumers of the results and program participants to define a targeted set of reports and dashboards. They include scorecards with drill down functionality, dashboards in trending view, system level metrics, executive dashboards, and issue management reports. It is extremely important that any reporting be actionable so consumers can act upon it. Automation of these reports is highly desirable, as skilled data and process analysts can work on other things rather than working on routine manual reporting activities. We also need to formalize operational environment in which assessment and scorecards are run. Data quality analysts and business analysts review breaks in data quality and issue management activities and then assign responsibilities. Operationally, the data quality team need to review the scorecard results and related error records at a set frequency, daily, monthly, quarterly, whatsoever business process cycle demands. It is important to establish plan, do, check, act activity, PDCA, what is being measured, what constitutes required action, by whom, and what action needs to be taken. Finally, the data quality monitoring process should be integrated into existing management routine and standard operating procedures. So with this, I would like to close the presentation with a quote from Colin Graham. Data quality requires a certain level of sophistication within an organization to even understand that it's a problem. So this 4-phase define, assess, improve, and control approach helps to carry out DQ projects in a systematic way. Having a standardized and structured methodology is important, so anyone in the organization can follow the same steps in implementing data quality. This also contributes towards implementing good program controls and project management disciplines. Thank you.